Hello, welcome everyone to question number 16. Implement stack using linked list from the topic linked list of Geek for Geeks most to coding interview questions. Just have a quick look at the question and we'll be discussing the approach. Before that, please don't forget to subscribe the channel. If you have any extra email IDs, please do subscribe with those. That will be very helpful our growth of the channel. So if you have any doubt after watching the video, please do comment down below. Now let's go to the approach part of the question. Coming to the approach, let's understand the meaning of the question first. Okay, the question is saying that we have to implement stack using a linked list. How will we do that? Let us know. So for that, first we have to know what is a stack. Okay, stack is a simple data structure where the elements will be pushed from bottom to up. Okay, this is a stack, for example, and in the input you can see 2, 3 and pop push operations have been used. Now we will use those similar operations and we will be doing a stack operation using the linked list. Okay, so this is a stack data structure. Okay, now he's saying we have to push 2. We have pushed 2. Now it is saying push 3. Okay, we have pushed 3 now. After that it is saying to pop. Okay, these are two push operations. Is one push operation. This is another push operation. Now when stack whatever the element, the last entered element. Okay, whenever pop operation is used, the last entered element will come out of that structure. Okay, so in this case, up to till 3 we have pushed. Now it is saying pop. Okay, now the last element that we have entered is 3, so that will come outside. Okay, let's represent in another color for that. Now 3 has come outside. Okay, in this here. Now again the next operation is push 4. After removing 3, 3 has gone. Now we are pushing 4 here. Now 4 has come. Okay, one pop operation. This is a pop operation. That's why we got 3. Now we have pushed 4 also. Till this part it is 1. Now again he's saying to pop now. After popping, only the 2 element will be remaining inside the stack. So 3 has come out. Now 4 also came out. Okay. Now you may have some confusion how it is a linked list. Okay, I'm trying to explain using the basic stack data structure here. I hope you have understood till this part. Coming to the linked list part here, how it is a linked list. These are all we have to convert them into linked list. Okay, this is the same way we have to implement this model in the linked list. What we have to do is we have to get the second element here, then add the next address and the data for that will be 3 here. Okay, similarly after we pop this element, 2 will be remaining. This is a continuous push operation up to this part. We have pushed 2, 3 similar to above. Okay, now in the linked list also, now we have popped 3. The 3 will come here. After popping 3, we are pushing 4 again. So 2, 4 will be connected here like this. Like this, in this similar way, we can remove this and 2 will be at the end of the remaining. 2 will be remaining at the end. So this is how we do in the linked list. I hope you have understood the approach till this part. If you have not understood, let's go to the coding part. It will be very much clear after seeing the code. Okay, in the output it is only asking the pop elements only. Okay, remember in the output we only need the popped elements output, which is 3 and 4 in this. Now let's go to the coding part and clear your doubts. Now we are inside the Geek for Geeks website. So have a look at this. The class is stack node has been given. So we have a constructor here which is used to construct a linked list. Okay, whatever the data will be given, that data will be converted to a linked list type. Okay, so this stack node class we are using here above this one. Okay, this is the data which is being given by compiler or interpreter. Now the data has been given. For let's take the left side example only. The two data is there. For two data, some address has been created randomly. Okay, now node is pointing towards the 2 value and node dot next means the next address to 2. The next address to 2 can be anything. So we are initializing that with self dot head. And what is self dot head here? Which is none here. So 2 dot next is pointing towards a none address. Okay, you also have to use this constructor. Okay, remember this constructor also. So now 2 dot next is pointing towards none value, and now the new head will be, the head will be 2 now. Head dot head pointing towards node value. What is node value? Which was 2, right? 2 address. So our head becomes 2 and 2 will be pointing towards the next none value, right? So what is happening is we are exchanging the value. If you carefully observe and draw one by one value. If you put one by one value and check yourself, what is happening is we are reversing the linked list here, but we are reversing element by element wise. Okay, so we are swapping these two elements and the linked list is being reversed here. So the benefit of doing that we will know in the pop function. Okay, now 2 is there, 2 is pointing towards none value and head is 2. Okay, now let's push another variable. Okay, let's take 3 now. Let's take this 3. Okay, if you're pushing 3, what happened? Just remember, now new node is 3. 3, some address has been stored, which will take us to the 3 value. Node dot next means 3 dot next. The address next of 3 is self dotted. What was self dotted earlier? Earlier was 2 because we have pushed it to, and then we have initialized new head as 2. So the new head, this one is the new head. The new head will be current element, which will be 3, and the previous head was there, right? The previous head is saying 3 dot next, 3 dot next, 3 next value is 2. So now 3 is pointing towards 2 and 2 is pointing towards none value. Okay. So in this way we are reversing the linked list here. The benefit of doing this is that we will get the values that we have to pop earlier. Okay. While we have discussed the stack value in the presentation, I told we are removing the pop elements from the whatever element we are adding at the last, that is the one we have to pop in the stack case. That is what we have discussed. So benefit of getting that value earlier is we can move one linked list value to the next element. Okay, that means we are moving one address ahead. Benefit of doing one address ahead is we will be removing that left side part. Okay, suppose here if there is no head, we will return -1. But if there is any value, then we will be storing the data. So this is the starting data. After doing two operations here, the linked list will be 3, 2 and none. Okay, 3, 2 and none are there in the linked list now. So data will store 3 value here. 3 will be stored in this case. And self dot head is moving to the next element value. Now if we move to the next element value, now the new head will become 2 here. 2 and none are the only values present now inside the head. So this data we are popping here. So 3 will be popped to the compiler. Okay. 3 is gone. Now 2 and none value are there. Now we are pushing 4 here. The 4, again the same thing happened which has happened with 3. 4 will come. 4 will point towards 2 and 2 will point towards the none value. So the new head will be 4 after this. Okay. Again after that we are popping here. 4 is new head now. 4 is stored here and we are moving one address above the given value. That will be 2 again. 2 and none are the only values which are remaining. 2 is pointing towards the none address. So the new head will be 2 here and the data popped will be 4. In this way we got popped 3 and 4. I hope you have understood. If you haven't understood, just comment on what is the problem. I will be quick to respond. If you have understood this, please give us a like, and if you have any extra email IDs, don't forget to subscribe. It is very much required for the channel to grow. And finally, thank you for watching till the end. Let's meet in another question.